Okay, so we are still continuing with optical instruments, and we have already seen the normal adjustment, how you can adjust the simple microscope in order for the final image to be at a near point. So here they can ask you to explain. When you're explaining, what do you say? Explaining, you just press send. They can ask you to explain. Okay, how it works. But explaining is very simple. You say that an object O is placed in front of a convex lens at a distance slightly less than its focal length. At a distance slightly less than its focal length. Then you say next point. You say the lens is adjusted until the final virtual magnified erect image is formed at a near point. Then you go to note in normal adjustment. Note in normal adjustment, we shall say that here the final image is formed at infinity. Of course, you know, for an image to be formed at infinity, then the object must be placed at the principal focus of the lens. That's all. So we have to draw the diagram. This is our diagram. Let's put this on here. Draw this one like that. Okay. We also draw this one. It should be parallel to this one. Should be parallel. Are they parallel? Yes. So this is object O, which is placed at F1. This is also at F1. The image at what? At infinity. Then we shall now say this is alpha prime. This is also alpha prime. This is the height of object H. So we shall say that magnifying power is equal to alpha prime over alpha. Then we say for unaided eye, we shall have this. For unaided eye, we shall have this. And this angle is alpha, this is the H. Then this is object O, but then it should be placed at the distance which is what? D. Then we say for small angles, in radius, tan of alpha, approximately to alpha, which is H over D. Then tan of alpha prime, which is tan. We normally use the triangles that your eyes can see. So our eyes can see this one. So therefore, this distance, this is a focal length. So it will be H over F. So when we divide, magnifying power will now become H over F times D over H. Okay? So the H is going to cancel. So if H cancels, our magnifying power M will not become D out of F. Like that. Then we shall go ahead, we shall do examples at once. Let us go to compound microscopes. Compound. Compound microscope. Then we say consists of use it to see nearby objects. Next, consists of two convex lenses. The objective of shorter focal length and eyepiece of longer focal length. Then from there, in normal adjustment, let's go to normal adjustment. As I said, the fine image is formed at the near point. At the near point. Then we explain. That's one. Next, we shall say the what? The object is placed in front. Is placed in front of objective lens. Objective what? Lens at a distance slightly greater than its focal length. Its focal. Then we say the objective forms the actual objective. We say the objective lens does what? Forms an intermediate image, which is real and inverted. I1. Okay? Then next, inside the focal plane of eyepiece. Next, the eyepiece is moved up and down, or is moved in and out, until the final image is formed at a near point, which is virtual and magnified, So there they give you 3 marks for explaining, then 2 marks for the diagram. So we're going to draw the diagram. I'm going to draw the diagram. Let me use the whole space. So this is what I talk about, that it has two converging lenses. So there is first lens here, and there is second lens here. Okay? So this one is of shorter focal length, objective. This is of longer focal. This eyepiece. It is longer because for it magnifies. It magnifies, okay? Then an object is placed where. So we first draw these lines. First draw these are called the construction lines. Construction lines. That's called construction line. So we shall say our image, the first image will be formed here. This one we shall call it I1. Then let me say this will be refracted like this. It's refracted like this. But then it has to be coming from where? From here. So this one we shall call it. I have the final image here. This is I what? This is I2. This is H2. This is H what? H1. Then you can complete the diagram. The object is here. Object O. Then here, complete like this. Passing through this. It's got to be refracted because this is F what? F0. It's got to be refracted and it has to be coming from here. So we're going to have something like this. So we have this, and this observers what? I. Such that the distance from here to here, this distance is our D, near point. Then this is our F0. This is formed inside what? Inside FE. Such that the distance from here to here, the distance here will become V0. Then the distance here will become U what? UE. And the distance from here to here to become what? U0. And then what is alpha? This objective H. Let us put H. Then H. Then here we shall put here. This is alpha. This is alpha. This is image. So the angle subtended is this one, alpha prime, alpha T prime. Then from here, we shall say that magnifying power is equal to alpha prime over alpha. Then for unaided unaided what? I. So we have the eyes here. For unaided what? We have this. This is H of object, H0. Then this is it. Here, this one is what? The object. The distance is D. So this is alpha. Then we shall say for small angles in radians. For small angles in radius, tan of alpha, which is H0 over D. Okay? Then tan of what? Tan of alpha prime, which is, what is alpha? Alpha prime is this, so it will be the opposite, that's H2 divided by adjacent is D. From here to here is D. So it is H2 over D. Therefore, the magnifying power will become, that is H2 over D times D over H, which becomes H2 over H1. So magnifying power can also be written as H2 over H0 times H1 over H1. I have not changed any meaning there. It has made the same, okay? So this will now become H2 over H1 times H1 over H0. So magnifying power will become, now this is linear magnification. H2, the height of image divided by the height of object. Remember, this I1 acts as the object for the what? For the eyepiece. So height of image divided by height of object becomes linear magnification of the eyepiece. So that's what? MA. Okay, times M what? M that one. Because this is the linear magnification of this, okay? So, which will now become, this is VA over FA minus 1, okay? Times V0 over F0 minus 1. Because we know linear magnification is V over F minus 1. So that means that our M magnifying power will become negative D over FA minus 1 times V0 over F0 minus 1. That is the equation for the magnifying power of a compound microscope in normal adjustment. Okay? Then we go not in normal adjustment. Go to not in normal adjustment. Not in normal adjustment. So here the final image is formed is at infinity. So we draw our diagram. These are the two lenses. This one and this one. So this is objective. This is eyepiece, like that. And then we first do this. Let the image be formed somewhere here. So the image is formed here. But then, if this one is to form the final image at infinity, then this should be at the principal focus of this. It should be at the principal focus of the eyepiece. Therefore, this image I, let us call it I, will become at FE, okay, like that. Then this one will be at infinity. They'll be refracted parallel to each other. Then we can complete the diagram. This. Then here we shall have that. That. Remember this one is F what? F naught. Have this. Then we shall now have final image at infinity. So this is O, this is H of object, this is H1, then this arm is alpha, this arm is alpha, this is alpha prime, this is also alpha prime. Like that. So here, this will be FA. Okay, then this will be up to here. This is V what? V naught, image distance, and this one can be called U naught. So in this case, we are going to say for unaided eye, I think this one holds. So we shall say for unaided eye, we have this. When the eye is looking at the object, when the eye is looking at the object like this, we call it unaided or naked eye. So the angle subtended is alpha. So, and the object is at a distance d, the near point, which distance is this? The distance of distinctive vision. So from there we have that. Then from the diagram, what's the diagram of alpha prime? that we use the triangles available. So this is alpha prime. So I shall use this triangle, which is H1, okay, over adjacent, which is FE. H1 over F1E. So magnifying power will become alpha prime of alpha, which is H1 over FE times D over H0. So magnifying power will become D over F0 FA times H1 over H0. But H1 over H0 is linear magnification, which is V0 over F0 minus 1. So we substitute magnifying power will become D over FA, okay, into V0 over F0 minus 1. Very important equation. But when I draw it, please make sure that these diagrams are correct and make sure that you use a ruler. Use a ruler just like the way I'm also using what? A ruler. Okay? So, you can go on and look at maybe one example. You go on and look at one example. Just one example. We are going to say that the objective lens, the objective of a compound microscope has focal length has F equals, that is for objective, has focal length of 2 centimeters, and eyepiece has focal length, eyepiece has focal length of 5 centimeters. Then we say an object placed at a distance 2.5 centimeters in front of objective. In front of the objective. An object is placed in front of him. Then we say the distance of eyepiece from the objective is adjusted the distance from the eyepiece to the is adjusted so that the final image is final image is 25 centimeters in front from eyepiece, from eyepiece. Then you can say find the distance between the lenses and magnifying power. Find the distance between the lenses and angular magnification. And angular magnification. So here what we shall do is sketch diagram first. You have to first sketch it. So they are telling us that you have objective. Let me say you have this, you have also this. That's objective. So F4 is equal to 2 centimeters FA is equal to 5 centimeters. Then you have this. An object O. Then you also have this. The image is formed here. Let's say the image is formed here. The image is formed there. The distance is what? 25. And then here, this is the image which is formed, I1, this is I1, I2. This one is placed at a distance which is 2.5 meters. And this one we shall call it V0. We shall call it U what? UE. The object distance for the eyepiece. Remember, this one acts as the object, and then the eyepiece uses it to form the final image. This one, with the distance being this. So now here we are looking for separation. That's V0 plus UE. So we have to first get V0 and UE. So what shall we do? We first say action of objective. Action of objective. This one is similar to those questions which have separated lenses. Okay, it's almost similar. So action of objective, if you get magnifying power, you've just realized that it is the product of the linear magnification, is it not so? So we shall now say that 1 over f equals 1 over u0 plus 1 over v0. So 1 over v0 will become 1 over 2 minus 1 over 2.5. So the LCM is 5, so our v0 will now become, when you use a calculator, you'll be able to get our v0, which v0 is same as 10 centimeters. Then next, action of what? Action of eyepiece. 1 over FE is equal to 1 over UE plus 1 over V what E. So 1 over UE will become 1 over FE, 5 minus 1 over 25, but this is a negative. Okay? So UE, here we shall be able to get our UE as our UE, we shall be able to get as 4.1, 4.1, 4.2. 4.2 centimeters. Separation is equal to V0 plus UE. Okay, so you substitute, which gives us what? Which gives us, that is 10 plus 4.2, which is 14.2 centimeters. Then the magnification. To get magnifying power is equal to M0 times M what? Times ME, which is V0 over F0 minus 1 into VE over FE minus 1. That's the magnifying power, which becomes V0. V0 is 10 over 2 minus 1, then into negative 25 over 5 minus 1. So this is 4 times, this is 5, negative 5, that's negative 6. So magnifying power will become negative 24. So the magnitude will become 24. Take the magnitude and you'll be able to get 24. Okay? Then there we shall add more other examples as we move on. Okay? Then maybe we can also advantages of using microscope with a final image at infinity. Advantages of using microscope with a final image at infinity. What are the sum of advantages? Number one, you say the eye is unaccommodated or the eye is relaxed. Number two, you say okay, that's one advantage, because when the image is at infinity, the eye is unaccommodated, unaccommodated or relaxed. Then the disadvantage is one. The disadvantage of using microscope at infinity is that the magnifying power or the magnification is reduced. The magnifying power or magnification is reduced. Now let us go to telescopes. You go to telescopes. Now, there are types of telescopes. We shall begin with the first one. Okay? Okay, what can you say? They are used in viewing distant what? Objects. Next, the eyepiece. The objective has shorter focal length. An eyepiece, the objective has longer, because it has to focus something which is very far. Has longer focal length, and eyepiece has shorter focal length. Next, in normal adjustment, the final image is at infinity. The final image is at infinity. Then they are classified into two. First one is refracting. Refracting astronomical telescopes. They are classified in two: diffracting and reflecting. Refracting and reflecting telescopes. So we're going to start with refracting astronomical telescope. Okay? Refracting, we'll start with the first one. Astronomical telescope. So I'm going to just explain how it can be used, okay? So I'm going to have so this is the principal axis in normal adjustment, in normal adjustment, okay? So we're going to have this. The parallel rays of light, the parallel rays of what? Of light, like that. We say the final image is at infinity. So they are going to bend like this, and this one is also going to bend like that. Also going to bend like that. Okay? This is formation of this image. Like that. But then this image coincides with the focal plane, coincides with the principal focus of this one. So this is at F0. So this one forms the final image at infinity, therefore it will be at F40. So in here, still the same. So we have this. Find image at infinity. Final image at infinity. So that rays from distant object. This is objective. This is eyepiece. Now this is alpha. This is alpha. This is alpha prime. This is alpha prime. So when we are explaining how it works, we shall come and say that the separation is such that or we can start by saying that the separation is such that the objective lens forms an image I of a distant object which coincides with its principal focus. So we start by saying in point number 1, we say that the separation of eyepiece is such that the objective forms an image I of a distant object which coincides with its principal focus. Then you say, next point, the eyepiece is proved in and out, because the tube is proved in and out until the image is formed at infinity. So when the image is formed at infinity, you are not seeing it using your eyes. You understand? You are not seeing it using your eyes. So then after that, you draw the diagram. So the separation is such a way that this one forms this image of a distant object at the what? At a point which coincides with its principal focus. This image formed is intermediate image, and this image is real, inverted, and diminished. Don't forget to put those properties. So this one, it acts as an object for eyepiece. Then eyepiece uses it to form the final image at infinity. So let us get magnifying the power. Magnifying power is equal to alpha prime over alpha. For small angles, in radians, for small angles in rads, tan of alpha approximately equal to alpha, which is alpha is h. This is h. This is the distance up here is f naught. The distance up here is f what? Which will be h out of f naught. Then tan alpha prime is approximately equal to alpha prime, which is h over f what? Fe. So magnifying power will become h over Fe times f naught over h. H will cancel, so magnifying power will become f naught over Fe. Separation of the lenses will become f naught plus f what? Fe. Separation of the lenses is equal to f naught plus Fe. Is that okay? Then we will also look at when not in normal adjustment. Not in normal adjustment. Find image formed at a near point. At a near point. So we draw. So this is objective. This is eyepiece. Then we shall draw. We shall start with this. is down. Another perfection line is here. Let me say the image is formed here. Then this one is the image of a distant object formed by eyepiece. Remember, it's formed at F0. You know, rays that are parallel, they converge at a point which coincides with the principal focus. But if they are parallel to the principal axis, then they are supposed to converge here. But they are not parallel to the principal axis. That's why they are converging here at a point which coincides with the what? Principal focus. Then here shall complete. Okay. Then we shall complete it here. Then and here we shall also do the same. Then we shall have this. Then we shall say this is alpha, this is alpha, this is image I, this is H, but then it is inside FE. So that this is UE, this is our F what? F0, and this is alpha prime. Okay, this is alpha. The distance, then here we shall have this is I2, this is H2, this is H1. The distance is what? The distance is D. Okay, so here we don't have an aided eye because you cannot see the star using your eye. You can't see the star using your naked what? Eye. So shall say magnifying power is alpha prime of alpha for small angles. For small angles in radius, we should have tan of alpha prime, which is H2 over D. Then tan of alpha, approximately to alpha, tan of alpha is this, that is H over FA, F0, H over F0. So magnifying power will become H2 over D times F0 over H1. So meaning that magnifying power will become F0 over D times H2 over H1. But we know very well that H2 over H1 is equal to V0. No, that's the magnification of eyepiece. So that is VE over FE minus 1. So we substitute. So magnifying power will become F0 over D into VE over FE minus 1. But VE is equal to negative what? D. Is equal to negative what? D. So that means that our magnifying power becomes what? Our magnifying power M will become F0 over D into negative D over F what? FE minus 1. Very important what? Equation. Very important what? Equation. So, now in this case, we shall look at disadvantages of astronomical telescope. What are the disadvantages? The disadvantage of seeing that the image formed is inverted. The image formed is what? Inverted. That is the disadvantage. Okay? Then, so, next time, we shall look at the examples, numerical examples, and see how we can use whatever we have derived to come up with the required solutions for those problems. Okay? Can stop there.